this video I have what I'm hoping should be a fairly quick repair. This is a Solartron 7045. It's a 4.5 digit bench multimeter. These were originally released around 1977, and despite its age it's got a specification that will give a lot of modern digital meters a run for their money. I actually purchased this unit about 4 years ago as a non-working eBay auction. I put in a very low bid and I was successful in winning it. But as I said, it was sold as not working. I didn't know what that meant. Sometimes they're just sold as not working because they're not tested. And I can't actually remember what the fault with this was. I believe it powers up but gives incorrect readings. We'll try it in a few minutes. But I hadn't seen one of these for around 30 years, and when I saw this one for sale, then nostalgia kicked in and I decided that I wanted to buy it. What I'll do now is I'll plug it in and we'll see if we can see what it does, what the fault is, and then see if we can get it repaired. I've now got it plugged into my bench power supply. This will do for just quick testing. I'll use the calibrator later on to calibrate it if I can get it working. So I'll set the bench supply to 1 volt. As I say, I believe it powers up, which it does. It's doing something, and I'll switch the 1 volt supply on, so it should now read 1 volt. So I've got the 1 volt supply switched on. And as you can see, it's not really reading quite what it should. Obviously that's not correct either. Don't know about that. It's got a temperature measurement range as well, but I don't have the sensor for it, so it's going to read 0 or whatever, so that's probably not very indicative of anything. So now I have the bench power supply limited to 100 milliamps, so it should be safe to plug this in. But again, we're reading 0, so it seems we're reading 0 on all ranges, both volts and currents. Okay, luckily the service manual is available for this. You can just download it and print it offline. It even includes the schematics and a description of how the circuit works, so I've got a fairly high degree of confidence that as long as it's not a very rare part that's failed, then we should be able to repair it. So I'll turn the supply off. Okay, so the next step is let's get it opened up, have a look inside and see if we can figure out why it's not working. Now, although I use one of these for a number of years, I've never seen inside one. I don't think the company I work for would have been very happy if the new boy had have started dismantling their expensive test equipment. And these were quite expensive back when they were released. So I haven't actually read the service manual yet, so I'm just playing this by ear. But these are the only screws on the outside that I have direct access to, so I'll take these out. And so we had quite a number of these, and they never gave us any problems. They were very accurate, never seemed to need recalibrating. Okay, now hopefully the top cover will lift off. Screw on the back. There we go. So one option that you could get with this was what's indicated on this sticker. There was a battery option where you could run the meter from batteries. I believe it ran for 2 or 3 hours from one recharge. The rechargeable NiCads D-sized cells, and this was an option, and it came with an add-on board. So we'll have a quick look at the schematic before we do anything else. And what we have, this is just part of the schematic and the part I'm going to check first. So we have a plus minus 12 volt rail, and it's quite interesting looking at this, the way that the battery operation works, and that there's an inverter. So we have the battery power coming in here. There's a regulator and inverter circuit that generates plus or minus 15 volts, and that is then fed through to these 2 points that feed into the plus or minus 12 volt regulators. So presumably there's a disable function somewhere that stops this running when you've got the mains switched on. Okay, so there's a relay that cuts this out when you've got the main switch in the on position. Okay, so I'll have a quick look around the meter. Now, one of the interesting things I saw in the service manual is that, like a modern multimeter, a lot of the functions of the meter are performed by a single chip, although I can't actually see that chip anywhere on the board. So the one I'm referring to is this one. It's a 40-pin DIL chip, which is why I'm surprised we can't see it. And it provides a lot of the functionality. It drives the display, it selects ranges, it deals with reference voltages, mode switching, gain switching, and it even drives the A to D converter. So this is kind of a dual slope conversion system. And one of the interesting things with this, and why it has such good long-term stability, is it uses a chopper stabilized measurement system. So for around half of each measurement period, it's actually clamping the input voltage to a known reference, usually 0 volts, and then it uses that as its baseline reference. So in other words, it provides a correction every time it takes a reading to make sure that if any components have changed through aging or temperature or whatever else, then there's an offset applied that corrects for that drift. And it means that even over very long periods you get very good stability with this. What I'll do is I'll try and find the device I'm talking about. I have to assume it's under here somewhere, because that's the only part I can't see that's big enough to house the device in question. So normally there'd be NiCads in here, and of course there aren't any. It doesn't look like any were ever fitted. I was expecting to see a horrible mess in here, but it's actually very clean. It's a very interesting system we have here of joining the batteries to this board, which I think is going to, yes, it's going to unplug. There we go. Okay, there we go. So that's the device I was looking for. So this is the all singing, all dancing control chip within the system, and it provides all these functions. The rest of the system is really analog and glue logic to make the rest of it work. Now we know the digital side is working, so we know this must be running to a certain degree. I'm hoping this chip isn't faulty, because if it is, then all bets are off. It'd be very difficult, and we may have to make our own version of this. The rest of it seems fine. There's nothing on the main board. The fuses are intact. Got a little bit of something going on down there, but I don't believe that would cause an issue. I can't see any burnt components or any caps on here that are bulging. So we can look back at the service manual. I'll just pop this back in. It doesn't need the battery compartment in to work, of course. Okay, so I think I've spotted what the fault is. I'll just zoom you into the meter, and if you want you can pause the video and see if you can figure out what the fault is. I'm just guessing at this point, but it does look fairly indicative, and glancing back at the circuit diagram, Okay, so looking at the circuit diagram, I think I've figured out what the fault is. So if you want to pause the video at this point, I'll zoom in, you can have a look at the circuit board and see if you can spot what the problem might be. Okay, so having a closer look, I don't know if you can spot what the problem may be. I don't know if this will come out on camera, so you may not be able to see it anyway. But what we'll do now is take a few measurements. I'll just zoom back out. So although I think I know what the problem might be, what we'll do is go through and take a few measurements and just confirm that, and also if you haven't guessed yet what the issue may be, then it might give you some clues. I'll just get the power reconnected. Get it powered back up. I'll bring in a multimeter and we'll just take a few measurements. So what I'm going to do here is measure the 12 volt rails, the plus or minus 12 volt rails at these two test points. I've had a quick look and I think I know where they are. Okay, so I just need to find a ground point, which I believe should be there. And then there are two test points here. We'll look at test point 6, which should be minus 12 volts, and that's fine. And we'll look at plus 12 volts. I'm expecting this to not be plus 12 volts, and it's minus 0.3, so that kind of confirms what I thought I saw. We'll have a quick look at the reference voltages. The reference voltage is quite interesting because it's chopper stabilized. There's a 6.8 volt precision reference Zener that's used in this, and there's a circuit to create a mirror of that, so it's a plus and minus 6.8 volt reference, and because they are derived from the same Zener, then if there is a drift, then they'll both drift by the same amount. And again, because it's chopper stabilized, that drift will be effectively nulled out. But if we look at the two references, see if they are what they should be. So minus reference is obviously incorrect, and the plus reference is also incorrect. So we're getting no reference voltages either. But that's not surprising. If we're getting no plus 12 volts, then we won't be getting a plus 6.8 volt reference, because it's going to depend on that plus 12 volt rail. That's why we're getting no readings on the displays. We don't have, none of the op amps will be running the way they should, and also we don't have a reference voltage, either the plus or the minus reference. Okay, so I'll turn it off and I'll show where I think this problem lies. If you haven't seen it already, it's on this card. I don't know how well this will come out on camera, but we've got some tantalum caps on this board, and both are fairly badly discoloured. So this one, they should be light blue, and they're very dark brown band in the middle. As I say, I don't know how well this is coming over on camera, but I believe that these two caps have failed. So they are 154 and 155. This board is the inverter board from the battery pack. Obviously these two contacts are for the two battery terminals. And if we look on the schematic, so the two capacitors in question, different values shown on here from what they actually are, but 154, 155 smooth the output of the inverter, which in itself shouldn't be a problem, except that if you recall, these 2 points, B1 and B3, are fed into these 2 points, so they're effectively in parallel with these two capacitors. So if we got a shorted tantalum, it would be across here, and obviously it's the one that's across the plus 12 volt that is causing an issue. It may have taken out the bridge rectifier, we'll have to check that, but the first thing I'll do is replace these two capacitors, and then we'll see if that brings back the 12 volt supply, see if that brings back the voltage references, and then we can check to see if the bridge rectifier has been damaged as well. So that's just these two capacitors. I'll go away, swap these with some new. They don't need to be tantalums. I'll put some high quality electrolytics in there, and that should be perfectly adequate for this circuit. Okay, so these are the two capacitors in question. You can see this one's fairly discoloured and this one's even worse. It's almost completely brown. So I've replaced those. I've fitted a couple of new electrolytics. I'll pop the board in and we'll test the voltages again, see if they are now what they should be. Let's get the meter back. Power it up. And we'll test the same points again. So minus 12, which was fine before, is still fine. Plus 12 is now plus 12 as it should be. And the minus reference voltage, a little bit low, and the plus reference voltage, that's a little bit lower. So these are mirrors of each other, so they should be very close. And that's kind of the point behind how this unit operates. It doesn't actually matter what the exact voltage references are, as long as they are mirrors of each other and as long as they're stable over time. Okay, so that's working fine. What I'll do now is plug the power supply back in and we'll see if we're getting any sensible readings this time. So select volts, and obviously that's looking more promising already. We are getting some fluctuations on the display now, whereas previously it was just reading 0 all the time. So we'll plug in the supply. It's still set to 1 volt, so we should now get 1 volt. This is in millivolts, it's auto ranging of course, so this should now switch to 1 volt. So as you can see, even though it's probably not been calibrated for probably 20 or 30 years, it's still very close. I know this supply on 1 volt is about 0.1 millivolt high, so that's very close to what it's actually reading on here. Now I'll run it through a series of tests to make sure that it's working the way it should, and I'll recalibrate it, but it's looking promising and I'm pretty sure we've got this fault fixed. I'll just change the voltage to 10 volts. So again, very close. And 20 volts. Yeah, very close. You can see it's a very good meter. It's hardly drifted at all, if at all, in decades. It will need calibrating, of course. It's inevitable that to a certain degree it's going to have drifted very slightly. I'll just quickly check the current range. So I've got the supply limited to 0.1 amps, 100 milliamps. We'll move the, and as you can see, we're fairly close to 100 milliamps. I know the power supply is not going to be particularly accurate in terms of milliamps, but I've got a current source monitor that's extremely accurate down to the picoamp range, so I'll use that to calibrate this in conjunction with a calibrated bench multimeter. But as you can see, it's looking like it's now working. I'll just quickly check the ohms range, see if that's doing what I expect. So if you recall before, it was just showing a short circuit all the time. And if I short these together, okay, I'll try a 150 ohm resistor. Fairly close, and a 100k resistor. Okay, not too bad. These are just standard 5% resistors, so it's not necessarily going to be particularly close. Okay, so I'll get the calibrator out, get this reassembled, and then I'll just give you a quick look at it once it's been put back together again. Okay, so that's the meter fully assembled. For anyone that's interested, this particular meter was manufactured in January of 1980, so it's coming up on 40 years old. I have recalibrated it. It's now working well within specification, and without further adjustment it will probably continue to be within specification for at least another 20 or 30 years. It's only 4.5 digits, but that's more than adequate for a lot of use. Quite a nice meter. and it would be nice if all repairs were that straightforward.